All right. Last little trick in our bag of tricks. Not the cereal. Upper and lower bounds. This will be a nice quick video because it's a nice quick topic. And again, it saves time. So the rule on upper and lower bounds is this. Another two-parter. When you synthetically divide by a positive c, c just being any integer, any rational, I should say. If each number on the bottom row is either positive or zero, then c is an upper limit on your zeros. And when you synthetically divide by a negative c, again, c just being a rational number, if the numbers in the bottom row alternate positive and negative, and by the way, zeros can count as either, then c is a lower limit on your zeros. Again, this is something that's going to save you time. Descartes' rule of signs helped us limit the number of positive and negatives that we could find, somewhat. This is going to limit it even more because it's going to let you know if the number you use is a max or a min, so you don't have to use anything greater or less than the number that you use. All right, let me explain this first. So we go through and we synthetically divide. All right, we got this. Say I use the number 2. And I'm just going to make numbers up. I don't know. 3, -1, 6, 8. Okay? I go through and I synthetically divide this. I'm going to get 3, 6, 5, 10, 16, 32, 40. All of them are positive. The bottom row, including the remainder, they're all positive. I divided by a positive. So that tells me 2 is my max. There's nothing greater than 2. Okay? So this is what they mean by the bottom row. All right, let's put it in action. We are going to take this polynomial divided by 1. And we already know how to do this. We don't need to watch me do it, so this is what you get. All right. Now, since bottom row is all either positives or zeros, 1 is an upper limit. I don't have to try 2, 3, 4, 5. I don't have to try any of that stuff. 1, that's it. Notice that 1 wasn't even one of the answers, but it still tells me that there's nothing greater than 1. So now if you look at these numbers, we're going to have, 1 and 2. Well, I know I don't use 2, but I could have 1/6. I could 1/2, 1/3. I could still have that stuff, which is less than 1. All right, now let's try it for negatives. It's the same exact function, and this is going to demonstrate that -3 is a lower limit. All right, well, we have positive, negative, okay? They all switch signs. They alternate. Therefore, -3 is a lower bound. Again, -3 wasn't even an answer because we ended up with 0 there, or we didn't end up with 0. But it still told us, hey, you don't have to try anything bigger than -3, or less than -3, I should say. All right, so again, this isn't any additional work. You're going to do synthetic division by numbers anyways, Now you just take a quick peek at what's left over on the bottom, and that's going to help you narrow things down. All right? Now, that's how you use it in a problem. You may get, if you're trying to find zeros, you may get problems that just say, hey, show that 9 is an upper limit of this function. All right, piece of cake. You don't even have to find the zeros for it. All you're going to do is synthetically divide, and if the bottom row, now keep in mind, we're dividing by a positive. We want to show that it's an upper limit. A negative can't give you an upper limit, just so you know. And so we're just going to synthetically divide and hope that the bottom row is all positives or zeros. Sure enough, bottom row, all positives or 0. Therefore, 9 is an, it shouldn't be upper limit, it should be upper bound. There's a limit is a specific term in math, and that's a poor use of it. And then let's prove that -1 is an upper limit for the same function. Sorry. My bad. Lower. You can't use negatives to find an upper limit, and you can't use positives to find a lower limit. It's very specific, so make sure you remember that. All right, here we go. All right. We have a plus, minus, plus, minus. It alternates signs. Therefore, -1 is a lower, what's the word? Bound, not limit. All right, and that's all there is to upper and lower limits. Adios.